Morning, everyone. Let's see, we're connecting. We are. Nice. So yeah, that's I've actually done some work since yesterday. I need to find a timer app for us to track time on this prototype, but I'm currently checking time on my phone, so we'll be okay. But anyways, yesterday we haven't written much code, but I'll show you what I did in the meanwhile. Let's first show you the results. So in more 2 hours of work, we can now place buildings or nodes, and we can connect them. Now, it's not like the game yet, but it's getting close. I don't have building types. They can connect wherever they want, like this. We can create a nice graph. There's no camera movement, by the way. The space is endless, and no camera movement at the moment. So that's currently what we're seeing here. I'll show you the code. So our data model building now has a name. It has a view, a sprite. That's what you're seeing here in the center. So this black thingy, the icon, is the sprite. And like I said, the designer can decide which sprite he wants. HP, which we'll use in the future, and connection distance. The connection distance is used to know if I can place a node next to another node. So 5 means 5 units, right? And if I'll go to the model, so I'll remove this for a second. And I'll make this 10. I can now connect nodes further on. I always search for the node closest where I'm trying to place the current one. Yeah? Like this. Which is nice. So that's that. Let's change that back to 5. It's a good number. So yeah, the instances always have a reference to the model. The model doesn't know anything about its instances, and the instances don't know nothing about their views. So you can see the basic architecture already happening. The instance has state, so instances have state, and models only have data, so they don't have the current HP. They just have how much HP does this building have. And position, right? The position in the game world, all the relevant state this entity needs in order to live in the game world. Now the connection instance, connection is another model that's just the line renderer between two nodes, between two buildings, which we'll see in a moment. This is like a small factory method I like to make when I use a lightweight version of the architecture of MVI. So building it returns building instance, so it's a factory method for building instance. Now, since this is Unity, which is kind of annoying because I can't control who can create building instance. Anyone can do create instance, building instance from anywhere in the code. I have no control over who can create the script, which is kind of annoying because I can create a private constructor and be done with it, and I know everyone must use this method. That's one of the things that's kind of annoys me in Unity. What I mostly do in production code is I encapsulate all of Unity's APIs, right? Because they're very basic. So instead of create instance, I'm creating a script that wraps around the creation process of scriptable objects and normal behaviors, and it can apply some logic of its own. So the create method takes a building model, right? This is a building model, and I should probably add model to the end. And a vector for position, where to position the building, and is it connected to another one? Now, the reason this is defaulted to null because we want the first building to be placed without any connections to another building. And maybe we want mechanically to allow placement of buildings without connections to other buildings. I don't think we'll need that, but maybe this allows us to do it. So this is where I initialize the instance. You can see I'm initializing all of its values. Now, since this is part of the class itself, you have access to private fields. Now, I'm not using private field because this is a prototype, but let's say that position was private, right? So you can see I can still go to value.position and set it because it's inside the script. Some people miss that. Yeah. So and I also set the connection, and I'm returning the value of the building instance. I also created a building view, and views always have references to the instances. This is now wherever I serialize something in the inspector in views, I'm meaning something that is encapsulated in the prefab itself. So if I go to building, and you can see I have this one building go view. You can see the view, the sprite is something that is inside the prefab itself, right? So that's to avoid the reference hell you can have in Unity. Like you have a couple of stuff in the scene that's referencing each other. If it's encapsulated in a prefab, then it's okay, it's fun, and it's a cool way to do DI, dependency injection. Okay, so I have a view, and you can see I also have a static factory method for creating the views. In this, I create the views by using the resources folder. Now, if I'm working in a production environment, I would probably use asset bundles or addressables, which are fun to work with, and they kind of let you do the same thing but less stringy, right? And even in here, I'm using a string inside the code. They probably create like a small, I don't know if a tool, but a file, basically a file that maps all the assets I need to load and unload. But this is like a cool way to load the building from the resources folder and do it programmatically, right? Not from Unity, which is kind of nice. That's the way I do that. I instantiate it and I initialize it with the building instance I get. And the view, of course, reads all the data it needs from the instance and positions itself in the world. The view is the representation of the instance. Right. Let's see connection. Connection is very straightforward. This is a lot like a graph, by the way. So connection is actually empty. It has no data. We don't need the data for now. So it connects two building instances, and you can also create it by giving it a model and two buildings to connect, right? And we're going to change this in the close future because we don't want we're using public fields, yeah? So I can get to building A and set its connection, but it's not really a good way to do it. We want a method to wrap around it, and we're going to need multiple connections to a single entity. So we're going to change this in the near future. The connection view is very simple. It's a line renderer, and I also instantiate it with a prefab. And you can see in the initialization, I set the positions of the line renderer to the positions of the buildings. And that's why you see the line renderer stretching between those two buildings. So that's that, and we have a God object, which will probably refactor, maybe refactor, because again, this is a prototype. Which the God object, I like to call it God because it's where I throw all the stuff I need to do. And once I see it's maybe getting too big or even too big for a prototype, I'll start extracting things outside. So we have, let's see, API for a second before we go into the code itself. So first off, it keeps lists of buildings, and see it's working with building instances because working with data, not with views. It's very important. It has references to the models, so it can instantiate new instances. In the update method, I'm trying to set new buildings with a click. And create building is a simple function to create buildings. We'll go into it when we change the code in the near future. And overlapping, but it's checking if I'm trying to place a building in that overlaps with the position of another building. So if I'll go to Unity for a second and press play, you can see I can't place a building on the same building, right? Not even in the range or radius of the building. I have to go at least radius wide away. Yeah, so that's that. And get closest building within distance. It will get the closest buildings to where I'm trying to place the new building, the new node. So it always creates the connection to the closest node. So if I'll open this again, just put the game here. Let's create two nodes. And if I'll try to place a node here, it will connect it to this node because it's the closest one, and here as well. Cool. So that's the code I've written yesterday, like 2 to 3 hours during the night. Today we're gonna revamp this. We're gonna add some more features. We're gonna see how the game works and take our favorite parts. Cool.